Okay, everybody, so I will present a little bit the details of the Microcensus project. This presentation is specifically related to Uruguay. As I highlighted during this morning, our objective is to calculate the size of population living in the catchment area of each vaccination site in Uruguay. And the idea behind the Microcensus is to validate and to compare the figures that we are able to get inside this within this catchment area with satellite estimated population, and in that specific case, we are trying to assess if we had like a good fit. The satellite estimated population can be like a reliable source to help us to drive targets for vaccination campaigns. And so the estimates and the comparison were stratified by gender and by age group, as I highlighted this morning. And I covered a little bit what is described here during the presentation of the workflow and how we define the priority areas for this study. So we did a multi-criteria analysis trying to incorporate insights from satellite images, streets, building footprints, vaccination sites, and prioritization areas. So we are able to cover overlapping of this information. Priority areas for the country, so specifically for Uruguay, we offer 32 municipalities in terms of options. They choose 5 ones for the Microcensus. And one of the key advantages of using this approach is that we are able to select sites where we're going to be sure that we're going to have all the information necessary to do the comparison that we need, and also the information regarding the buildings, because this information is critical for us to kind of estimate the work needed for the field, for the data collection process. Okay, if you are interested in the bingo autograph stuff, a lot of people asking, how are you using satellite estimated population? So these sources are free, they are open. These are the sources that we are using and we are comparing. So you have WorldPop, Meta as part of the AI for Good initiative, Global Human Settlement Layer, and also GPW4. So you can download and access this information. Maybe this can be useful for your work. Okay, this is the representation of the enumeration areas. So for each one of the areas that we need to visit to the country, we have categorized the sample area, and we identify the building footprints. And here we have the first challenge that we went through. The building footprint algorithm that was basically creating AI and remote sensing was not accurate, especially for South America. So here we got like a few buildings, and when we start to visit this area, we got 10 times more. And this is a challenge if you need to specify the amount of time that you're going to need to cover and to collect this information, and also the number of enumerators and so on. So to address this, we divided the data collection process in 2 rounds. The first round, we visited this area, mapping the households and using the entity list, and this is when we got the second challenge. Oops, sorry. As highlighted, we have, for example, if we have a building, we have like apartments, and they are registered into the entities section of ODK Central in the order that they were collected. Okay, if you need to navigate to 100 tens of entities to find the one that you are filling the information, okay, but at the end we have 6,000 entities. So during the data collection process, this was a challenge because the enumerator needs to go through a list that is pretty extensive to try to find where he should put the information regarding the number of people, the gender, and so on. And at that time, we didn't have the feature to search to the list. Now we do. And the solution that we implemented to address this was to take the list of entities and convert it into a form option. So basically, we created an R script that was capable to extract this information on a daily basis, compare this information with the survey already into the database, create a difference, and upload this information to a new version of the form. So every day we updated the form to incorporate and leave only the options regarding the address not currently collected. This was able to create the circumstances for us to decrease the number of options that the enumerator needs to navigate to. We combine this with cascading filtering also. And we are using this, we are able to sort the list of addresses that needs to be collected. So we use this approach specifically in Uruguay. Now we have the search through entity list available in LDK, so it's much easier for you if you have a lot of options to navigate through. And we use this Power BI dashboard to control the data quality process. Basically, we're connected to the endpoint available in LDK, updating information at every 15 minutes. And this is the representation of the points that is a critical information for us, because the location will allow us to compare the figures that we got from the field with the figures that we got from the satellite estimate. Thank you.